So for the sake of the recording, I'm just going to do a quick review. We're calling this distance here distance A. That's why it's A comma 0. Same distance would be in this direction, therefore it's negative A comma 0. On the horizontal axis, we're moving up A units, therefore it's A 0 comma B. And if we move down the same direction, it would be 0 comma negative B. So let me get rid of that scratch. And then we're calling the distance to the foci distance C. That's why we've got C comma 0 and negative C comma 0. So those are those basic points. Now we know, and then we also put a random point out here, x comma y. And we're trying to relate x comma y to the broken line, or the distance of the broken line, which is the string that kind of creates all of those locus on the foci. So we were going to find the distance, and we were going to start with this segment that I'm highlighting in red. And in order to do that, we're going to do the distance formula. That is the square root of, what is it, x sub 2 minus x sub 1 plus squared. You guys remember that formula, right? Okay, so starting with the second x, which is xy, that's going to be x minus this x, which happens to be a negative c, quantity squared, plus the y minus 0, quantity squared. So there's that distance in red. We need to add to that the other piece, which is this piece right here. So I'm going to just do that in blue real quick. So plus, and again, distance formula one more time. The square root of x minus c, quantity squared, plus y minus 0, quantity squared. And that equals some distance. That equals some distance. Now, we didn't know the distance of the string we created. We don't know the distance of the string that creates this. Therefore, it has to be some type of general form, right? Are there any questions on anything I've done up there so far?
What are you trying to prove?
We're creating the formula for an ellipse. So what do these two things represent?
The length.
It's the length of the distance or the length of the string.
String?
Of the string. Yeah, you missed that part, so I'll show you guys in a little bit, okay?
Okay, thanks.
We need to find question mark. Right? So, let me put up some hypotheticals here. Delete this. Oh, not paste. Undo. Delete. Okay. So, if we take this point xy, we can actually rotate it and put it at any point on this ellipse, right? It would still be the distance of these two things, or the sum of those two roots. Let me put it right here, right on that point. Do you guys see where I put it? I put it right there. Now, I don't have to call it x comma y, do I? What does that point become? A comma 0. Everyone understand that? So that means that this string, or those two distances, would technically be this distance. Let me go ahead and, it would be this red distance, right? And it would be another piece from the blue one. Does that make sense, everybody? So that would be the broken lines, right? So I'm going to try to find those distances, because that's going to produce something different for me. And I'm going to do that on a separate page. Actually, I can do it down here, can't I? Could probably fit it right there. We can still see the values. Good. I'm going to use green so we don't confuse it. Is that cool? Wow. So here we go. Let's start over with A. So it's the square root of A minus what? Yeah, negative C. Or did you want to do the red piece first, or blue piece first? All right, so let's do this one first, okay? So it's A minus a negative C, quantity squared, and then we're going to have plus 0 minus 0. Cool, I like that. Yeah, squared. Let's not forget to square the 0 minus 0. plus the blue section now. And that's going to be, yeah, a minus c quantity squared plus, oh, nice again, 0 minus 0 squared.
Shouldn't it be 2? Shouldn't, like, the last piece, that last piece that you wrote down, the quantity squared, a minus c squared plus 0 minus c squared, be like 2, like,
No,
shouldn't you have 2 of those pieces?
it's x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared.
No, but I'm talking about since, like, because there's 2 of the same piece up here, shouldn't you have 2
No,
pieces?
because one is the red line, which is this piece. This is the red line, and this one is the blue piece. I know what you're saying there, but it's not 2 of them. One is the red piece and one is the blue piece. What's up?
Are we proving that the string length is going to be the same, like, throughout, or what are...
No, we're trying to create that formula. Remember the nice formula we liked?
Yeah, okay.
Because here's what I'm going to tell you right now. We've just done this. Let me go ahead and delete this real quick. Delete this. Delete this. And delete that. So here's what I want to say real quick. Everyone understood what we did here? Technically, what we've created is the formula. But do you like the way that looks?
Of course.
That's technically the formula for the ellipse. But I don't like the way that looks. Do you like the way that looks, Skylar Laura? That just, bleh, right? So what we're going to do is we're going to clean it up, okay? So let's start by cleaning this piece up. Let's make that nice and big again. So let's see what happens here, okay? I was using green. So on the left side, this is just a plus c quantity squared, correct? Because do I have to worry about 0 minus 0 quantity squared? No, that's just bleh. And I'm going to add that to the square root of a minus c quantity squared. Because 0 minus 0 squared again is just 0. Chef?
Yeah.
Very good.
Now this is cool. This quantity is squared, but I'm taking the square root of it. So those are kind of like opposites of each other, aren't they? So I end up with a plus c plus a minus c.
Combine like terms. Combine like terms.
Combine my like terms. C minus c.
2A.
2A. No,
So
it can't be just 2A.
So it's just 2a.
No. You're lying.
Does the math lie, sir? Now I'll show it to you in another way, okay? And then you're gonna go, oh, duh. Of course it's 2a.
Does young Metro trust this one God? Latin literature. Beautiful.
Oh, you letting him tell a joke? You can't let him tell a joke. Is it one of your pizza joke? Never mind.
No, I'm not.
Can I move on?
Nope.
So we're saying, so we're saying that this first part that we created is also equal to 2a. So what I'm going to do is I'm going to take this formula that we started with, the very first part, come on, and I'm going to set that equal to 2a, because all I did was simplify the other part. Does that make sense? Now, I want to point you back to something that Benjamin was saying. If you think about this, didn't we just find the red line plus the blue line? And over here from C to A, the line is doubled up, isn't it?
Yeah.
So if we just took this blue line and just moved it to the other side, isn't that technically the whole length? So if I go from here, from here to here, that's called A, and from here to here, that's also distance A, then what's the distance of the whole ellipse across?
2A.
2A.
Amazing.
Okay, but is that proving it?
No.
What we did in math is proving it. Okay.
Can you go back down?
Okay, so here's where we're at. the left side as well. The right side cleaned up real nice, right? Now we just gotta clean up the left side.
Cat choked by boa constrictor.
What are you doing Wednesday? Oh, what do you guys do Wednesday? That's correct.
It's gonna be our final reviews because we test on Thursday, Friday.
What are you do? Are you doing something on Canvas or what?
Maybe.
Because I'm not gonna be here Wednesday, but it's okay. Lord.
Sad.
I'm not gonna be here on
Python attacks not here.
I'm gonna go to koalas and play something. Feed a koala a leaf.
with a koala leaf.
Alright, can we continue then?
Hold on.
Wait. It's still over. Right there, yeah.
Metro, who did you want someone?
Is that a negative C for red?
Yes.
Wait, you saw it wrong.
Oh my god, there's like 4 fingers. Yeah, I know, there's 4 fingers. Yeah, because we keep this one. We keep the yellow, this one goes to the cashier. This one goes to the registration.
You can really even see it on the screen.
Okay, looks like we're ready to go.
Yeah.
Let's clean this up. Let's do the red piece.
I need to do this.
That is the square root of the quantity x plus c squared plus y squared. And in the blue part, x minus c squared plus y squared equals 2a. Now, I want to clean this up, but I've got some radicals. If I tried to do my squaring for both, I would actually make this problem messier for myself.
Don't make it messier for yourself.
So, thanks. So what we need to do is we need to move one of those to the other side.
I thought you can't do that.
Yeah, sure you can. It's a subtraction property of equality. Serious?
They're in the same.
So if I went minus x minus c quantity squared plus y squared, don't I have to do it to the other side?
Well, I was kind of, I didn't know what you meant. Okay.
Subtraction property of equality. So here's what it's going to look like after that. It'll look like this right here. I will have that the same, which is the square root of x plus c quantity squared plus y squared is equal to 2a minus all of that, which is the square root of x minus c quantity squared plus y squared.
You just move it over.
Yeah, that's all I did. Just moved it over.
So what did you move over?
This right here. All this went to this side. So if it was positive, it becomes a
Negative.
negative.
Easily.
And we're just going to go as far as we can until the bell rings.
And it's equal to 2a because the other thing you
It was already 2a, right.
Okay.
There was already a 2a on that side.
I forgot my.
Are we good here?
How do you feel about teaching?
I love teaching.
It's fun.
You have to.
I want to get rid of this radical first, so I'm going to square this side, which means I have to square this side. Now the nice thing about squaring the square root is that I'm left with what's inside. So this simply becomes the quantity x plus c squared plus y squared equals.
So you're squaring them to get rid of the radical.
Right, see how I dropped the radical here? But if I square this left side, I have to square the
Other side, right?
right side of the equation as well. And this is where it gets a little,
Funky.
yeah, a little weird because I'm taking that whole thing times itself. Which means I'm going to have to use my good old property.
Wait, so if it gets rid of it on this side, wouldn't it get rid of it?
No, because this is a number. 2a minus something, or something minus something is something, isn't it? It's still a real number. Because of the identity property, I can't do those separately. It's one number. If you think about, I mean, I know it's kind of crazy, but if you think about this, 3, or let's go with subtraction problem. If I said 6 minus 2, well, 6 minus 2 because of closure is just a number. That number happens to be 4. So what you're saying, if I squared both sides, then I would get 36 minus 4. Is 36 minus 4 the same thing as 4? You see how that doesn't work? So we have to stick to our closure property. It's one quantity. I have to keep it together. Okay? And unfortunately, it's not nice, but we will be okay. So here's what this is saying. This is saying take 2a minus the square root of x minus c squared plus y squared and multiply it by itself. Minus c squared. That's what it's saying, right? Everyone agree?
Yeah.
Cool. I'm going to leave this red piece alone for now because I want to write this bigger because it's kind of hard to see that, isn't it? What's up?
Why are you squaring it again?
I'm not squaring it again. I'm writing it twice. The green part says square it, so that means I have to take it times itself, don't I?
Yeah, I guess that's what I'm saying. Why did you, the 2a minus the, that square, why did you square that?
It's already squared. Here, if I close up that green, see how they're squared? I didn't do anything to the inside. I'm just rewriting the blue 2 times because that's what it's saying. Here, think about this. If I said the quantity x minus 3 squared, how do I write that? It's x minus 3 times x minus 3. Correct? So that's all I did is just rewrite it twice so I can multiply it. Because I'm going to have to use, what do they call it? The starts with an F, ends with an oil? Oh, yeah, foil. Thanks. There you go. So, you guys ready?
Left
2a times 2a is 4a squared. 2a times that craziness is negative 2a craziness. So x minus c quantity squared plus y squared.
Isn't that a negative number? Never mind.
Okay?
I understand.
So we did the 2a already. Let's distribute the second part. So craziness times 2a, that is negative 2a craziness. X minus c squared plus y squared. And finally, craziness times craziness.
Can't you just square it?
Right, so it's that thing squared, isn't it?
Yeah.
So it's going to be positive something squared, and that something is x minus c squared plus y squared.
Oh.
Right.
So the square root cancels.
Here it does, doesn't it? That's nice. So let's clean this up. That's just 4a squared. These two middle ones are like terms. So that gives me negative 4a square root of x minus c quantity squared plus y squared.
Minus plus x minus.
Yeah, because this is going to drop, isn't it?
Is it negative?
So that becomes plus
Wait.
the quantity x minus c squared plus y squared.
Okay.
Cool?
How come it's not negative if we?
What's negative times negative?
But you're combining like terms, not multiplying them.
These two got combined. Those are negative. But to get this one, I had to go a negative times a negative, and that whole thing became a positive.
No. I'm talking about why isn't the second x minus c? Why isn't that whole bracket of negative?
It wasn't negative to begin with.
But you're multiplying it by a negative 2a.
I'm not. That's a positive 2a.
Go down, right there. Yeah. See? Never mind.
These are being combined,
Okay.
so those are okay.
Oh, he's excellent.
We're good?
There's a 4.
Not convinced yet?
And since it's yeah, you could just cancel because it's a square root. Right?
No. Again, we've got that closure in here. So I can't do that, even though they're both squared. I can't do that. I know. Okay, don't forget that all of this is still equal to the left side, right? And the left side is right here, which is x plus c quantity squared plus y squared. Oh, that's nice. Do you guys see the y squares on both sides? Those can cancel. So you're gone. You're gone.
But they're both positive.
Well, if you went y minus y squared,
Okay, sorry.
right? Okay. So those are gone. All right. Let's try to make this a little bit messier before it gets nicer. What?
Can we cancel out the? Oh, wait, never mind.
No, one's positive, one's negative. But I like where you're going with that. If this is gone, here's what I want to do. Focus just on this, on this part. That becomes x squared plus 2xc plus c squared, doesn't it?
Yeah.
And if you focus on this piece, that becomes x squared minus 2xc plus c squared. So I like where you were going with that. I think that's what you're trying to say. But then now we have x squared on both sides, don't we? You see that? So x squared and c squared, yeah, and c squared also. Those would drop out of the picture. So we would have 2xc is equal to 4a squared minus 4a square root of x minus c quantity squared plus y squared minus 2xc. We would have this. Right?
So these cancel out.
Now that's nice because I've got a negative 2xc on that side. I can use my addition property of equality and add it to both sides, which would actually give me 4xc is equal to 4a squared minus 4a square root of x minus c squared plus y squared. Because I took this to this side. Right?
Yeah.
Cool beans. Algebra.
Can you give us a break to catch up?
Yes. Call me Casey.
I hear a joke.
Not Ravana.
After class, Mr. Yost.
You catching up?
Wow, all this math just for simple problems. Yeah, well, it's not simple.
I moved the negative 2xc. I went plus 2xc
Except to be
plus 2xc. So that cancels. Okay. Now, here we go. I still have one radical over here. I want to get rid of that.
Even if you have 3, though.
So this is, I'm going to have to move some stuff over. This becomes 4xc minus 4a squared equals negative 4a square root of x minus c squared plus y squared.
Why did you move it?
Because I need to isolate the radical so I can square it.
Square it?
Yeah, because that's how I get rid of radicals, don't I? Before I can square it, I want to get rid of that negative 4a. Right? So divide this by negative 4a. I'm using my division property of equality here. Divide by negative 4a. That makes this 1, and hallelujah, I've met my goal of getting it by itself. Let's see what that does to my left side though. 4 over 4 is 1, so that becomes negative xc over a plus a. Because the negative 4 over negative 4 and a squared over a is just a. That equals the square root of x minus c quantity squared plus y squared. Would you guys prefer to leave it as one fraction instead of two?
Yeah.
Yeah? Okay. So let's do that then. That would become, let's see here, xc minus a, plus a over a. And this would have to be a negative xc. Negative xc. Yeah, I'll let you guys catch up on that.
It says 42 minus 40
Oh, yeah.
equals.
Somebody hung up?
No, but it's an out of, not school number. All right, we're cool? Moving on. Now I can get rid of that radical by squaring it, but
Yeah, just do it.
I've got to square this side. So here's what we're going to get.
That becomes 1.
On the left side, the denominator is just a squared, isn't it? Because what's a times a?
A squared.
A squared. But the numerator, I'm going to have to follow that bad boy. So negative xc times negative xc is going to give me the quantity xc squared minus 2a xc plus a squared. I think I got that right.
Double check.
You guys double check? Double check, check, check.
It was a different scenario, so.
That equals x minus c quantity squared plus y squared. Yay! To your love. This is algebra, homies. Algebra at its finest.
At its frustratingest.
What if the a squared on the top is cancel off though?
I can't because remember the top is just some number, isn't it? Now if you want to separate it, we can. So this would become, let's see here. And I think we're going to have to at some point because remember we want the whole thing to equal how much? 1, remember? It's the x squared over a squared plus y squared over b squared equals 1. So we wanted to equal 1 anyway at some point. So I'll go ahead and expand this for you guys. That becomes x squared c squared over a squared minus 2xc over a
My brain hurts.
plus 1.
Wait, what?
That looks crazy. Maybe we shouldn't go this way.
Yeah, let's not do that.
Okay, let's not go this way right now. Let's go. Shh. Are we almost out of time?
Yeah.
I'm going to keep going till the bell rings. And then we'll finish it.
The bell is going.
How? When? Now?
47. 2 minutes.
Oh, 2 minutes. Okay.
No, that's enough.
So let's do this then. Let's multiply. Let's multiply both sides by a squared. That means I got to multiply this by a squared. That's going to make this 1. So I've got the quantity xc squared minus 2axc plus a squared equals
I have no clue.
Question marks.
a squared times woo, x squared minus 2xc plus c squared plus y squared.
Please take a chill pill. Hang on, we're students. Remember.
Okay, let's pause this then because you guys are already. Yeah? Okay. Yeah? I had to factor this right here. Foil it.
Oh, okay.
I had to foil that. Okay? Have a good one.